This is to help you make corrections on 8.1 exercises that I gave you as an assignment back on March 16th. I'm sorry that you have to make some corrections. It looks like you've made a few mistakes. So I'm going to give you some of the answers. I'm also sending back your big ideas to you to make those corrections and resubmit them. You need to do that by Friday, which you should have plenty of time to do it. And you can also use the answers that I'm going to give you here. There's going to be 7 of the 17 questions that I will give you answers to. You might have more corrections than that to make, so I want you to double check, go over all the questions that I gave you, and make sure afterward that you have all the answers correct. Okay, so let's get started. The one thing I noticed, exponents are repeated multiplication, and some of you were adding, which is not what that would mean. This is the base of 4 raised to the 4th power. And what repeated multiplication form looks like is just writing the problem out as repeated multiplication, 4 times itself 4 times. The value, when they ask you the value of a power, they want you to actually calculate this out. So here's how I do it, and you can do it differently. If you want to use the calculator on big ideas, it's fine. You can go ahead and do that. I've given you that option. But what you want to do is, what I do is I actually group together my numbers. I know what 4 times 4 is, and that's 16, and I have an additional 4 times 4 with those two here. And then I take 16 times 16, and then I find my answer is 256. And that's really what they're looking. When they ask you for the value of a power, they want to know how much is it worth when you calculate it out. The second question, and by the way, pause this video if you need to so that you can make corrections on your work. The second question is asking you to find the value of the quantity -8 when it's raised to the 2nd power or squared in repeated multiplication form. You have to remember something, that this is a quantity. Whenever you get numbers in parentheses, it becomes a quantity. So everything inside is repeatedly multiplied. So you would take a -8 times another -8. And when you rewrite this as a power in repeated multiplication, you leave it in the parentheses. The second part that I noticed is that you cannot forget about the rules for integers when you do this. So here's the repeated multiplication form, -8 times -8. Knowing that a negative times a negative is a positive answer, you need to make sure you remember those rules when you actually calculate it out. So a -8 times a -8 gives you a value of this power as 64. Okay? So you need to remember that you actually have to have that integer rule when you're calculating your powers. Okay, the next question. Question 10. Now remember, if you had any errors between question 2 and question 10, you would want to make those corrections as well. The first page that I just showed you should help you make all the corrections in between there. The next part I noticed was that people were not looking at these as quantities. This is the -t inside each one of these parentheses. And whenever you have numbers inside parentheses, that is your base. The base is the whole entire thing inside there. And you need to write the parentheses when you're writing it as an exponent. So this is a -t inside of all of these parentheses, which means that my answer should be written in parentheses with a -t, and to that I need to attach the exponent. This is 1, 2, 3, 4, 5 of them. So the -t has been multiplied 5 times. Notice how that quantity, -t, is inside the parentheses. It should stay that way. If you look at question 11, there is a difference. Here you have a different base. The base itself is inside the parentheses. The base itself is inside these parentheses as well. But if you look inside the parentheses, your base here is just a +7. Okay, you have a +7 base. And that is not negative. In fact, is not inside parentheses. Each one of the 7s is inside parentheses. Your exponents should not be written inside parentheses. And how this is correctly written is with the -7, the negative outside, the 7, and the exponent attached to it. The exponent really attaches itself to whatever's being multiplied, whatever the base is. So the exponent attaches itself to the base only, which it is doing here. The negative sign goes in front of that answer, and that really there is a difference. The base here is 7, and the negative sign is multiplying the quantity inside the parentheses. Your answer here would be negative, okay? What the negative sign outside the parentheses means is that you should find the value inside the parentheses first and then apply the negative number to your answer. Okay, and that will become important to you when you're actually doing this down the line to find out if a number is actually positive or negative. Question 13. Question 13 tells you to evaluate an expression and find the value of expression. And really all they want you to do here is calculate it. When you multiply 5 times itself 2 times, you get 25. And that's really all you're doing is you're taking whatever expression is here, you're writing it out. This one would be 5 times 5. And then you are solving for that value. And that is the value of that expression. Okay, value of this expression is negative 11 to the 3rd power. The negative sign is not part of the base. Here the base is just 11. It is not inside parentheses. The exponent attaches itself only to the number directly next to it, to the 11. If the number was in parentheses, then everything inside would be multiplied. In this case, 11 just gets multiplied, and the answer is negative because the negative sign is in front of the number. And that isn't going to make a lot of sense to you right now, but eventually it will. So what that means is it's 11 times 11 times 11. Notice I put it in parentheses like I had for that previous question with the 7s. Then again, 121, because 11 times 11 is 121, times 11 again. And the total answer here is 1,331. The value of this expression, it says negative applied to it, is negative 1,331. There is a difference. You need to multiply it without the negatives and add the negative to your answer when it is not inside parentheses. The 2 main times that you use parentheses when you're working with exponents is when the base is negative, a negative number, and when you're using a fraction. So you did have a fraction here in one of your questions, and I wanted to show you how this works. If the exponent attaches itself to the whole fraction, it's written inside parentheses like this, and the exponent is written outside the parentheses. This is different than no parentheses and an exponent attached to either the numerator or the denominator, which you will see in the next section. Okay, so with fractions then, when you're calculating the value of a fraction, you would multiply the number that is attached to the exponent and multiply them repeatedly the same way you would do any multiplication of fractions, where you multiply numerator times numerator and denominator times denominator. So let me show you this first value here. This is the quantity of 2/3 raised to the 2nd power. And if I wrote that out, it would look like this. Okay, so it's 2/3 times 2/3. Multiplying numerator times denominator, you get 4. Multiplying denominator times denominator, you get 9. So this would be the value of the quantity 2/3 to the 2nd power. It's different than this second expression, or expression and example, 2 to the 2nd power divided by 3, or over 3. That's different. There's no parentheses here, so the only thing that gets repeatedly multiplied is the numerator, the one with the exponent attached. So this would end up being 4/3. I hope you see the difference between when you have parentheses and it's raised to a power, where everything inside gets raised, multiplied to itself, and when you just have part of it. Okay, so here's an example that I wanted to show you. This is 1/2, the quantity 1/2 raised to the 6th power. And how you write that expression or those repeated multiplications, it looks like this: 6 times 1/2 times itself 6 times. Now, when I'm evaluating this and I'm finding the value of this expression, if I look across the numerators, they're all 1s, so I know that 1 times itself 6 times is still 1. Down here on the bottom, for the denominator, I'm going to group them again. I'm going to group each set of 2 and multiply them out. And when I'm done, I have 4 times 4 times 4, because 6 2s becomes 3 4s. 4 times 4 is 16. And then I just have this 1 4 hanging out here by itself. 16 times 4 is 64. So now I know the denominator's value. And then I can go ahead and write my fraction. The quantity 1/2 raised to the 6 powers value is 1/64. Do you see how that works? Numerators times numerators, denominators times denominator. I'm not really sure how this would work on your calculator that Big Ideas gives you, but you could do the numerator part first, and then the denominator part to find your answer. That's a perfectly legitimate way to solve that. So lastly, now I need you to go back to your Big Ideas and make your corrections using the information that I just gave you on this video. And I can give you additional tries going forward on Big Ideas, but I don't think I can on the ones I've already sent you, sorry. But at least you have these problems that I've solved for you, 1, 2, 10, 11, 13, 14, and 16. So you have at least those 7 answers that you can correct and make corrections to any of the other answers that you got wrong. But you have this video to help you. If you need any additional help, please rewatch my first video or use the Big Ideas help that's available to you with videos and try it again. Okay, we are going to have an exit ticket on this. There will be a assessment for this, so I want to make sure that you get it correct. If you have any other questions, please email me. I'd be glad to help you, and please take care. Good luck with your work.